This is lecture number 5 of the course AU 203 Statistics and Quality Control. In this lecture, we will talk about the measure of dispersion, and dispersion means the variability of the data. Just like measure of central tendency, there's measures of dispersion like range, mean deviation, mean absolute deviation, variance, standard deviation, and the last one is the coefficient of variation. There are some other measures like quartiles, which we will do it in the next lecture. But these are the few of the measures which we are going to address in today's lecture. Okay, so when you talk about measures of dispersion, or actually what we call it a variability. So dispersion or variability means the same thing. So when your data has a spread, so central tendency is actually where most of the data is lying. So the measures of dispersions or variability are representing how your data has been spread, and most of the time we are interested in how it is spread about a mean. For example, if we are packaging any food product, let's say the package weight is, let's say, 10 grams. So what we want as a producer or as a consumer, that every packet would be packaged with 10 gram of a product. But some product would be less than 10 grams, some product would be more than 10 grams. So if it is more than 10 grams, it means it is a loss of the producer, because consumer is getting paying the price of 10 gram but getting more. Or if the package is supplied with less than 10 gram, it means customer is paying for 10 gram but it is not getting the required amount. So in every package of the food, there is always a chance of variability. So let's say what we call it 10 gram, in that case would be the central tendency, but we are interested in how much is more than 10 grams or how much is less than 10 grams. This is something we can work out through different statistical measures, and we call them to be measure of dispersions or measure of variabilities. Few of them we will address. Range we will talk about today, mean deviation we will talk about today, and mean absolute deviation, variance, standard deviation is one of the important one, and coefficient of variations, and interquartile we will deal in the next lecture. So let's say if we just the two data sets. So for example, data A has more central tendency toward 0.20, and the data B also has a central tendency toward 20, but it is much more spreaded than the data A. So we can say from this dot plot of the two data set A and B, that data B is having a wider spread or variability compared with data set A, and data set A is more towards the central data point, that is the 20 value, and some are less than 20, some are greater than 20, and but here even some data point are 0 or 40. So there is a bigger spread of the data in data B compared with the data A. So but the thing is, before even visualizing, how can we quantify that amount of variability in the data set? So let's say you have two data sets, and there are 5 data points in each sets, like x1 and x2, and if we calculate its mean, we see from the mini tab that both x1 variable and x2 have the 5 number of points in the data set, and their mean value is same. So if you add them together, divide by 5, you are going to get 10. And the same is the mean of the data set 2. 2 also has a mean of 10. Then what we look at, because this measure of central tendency doesn't give an idea about what is the characteristic of that data. So these two data sets, how they are different, because they have the same mean value. Or you can think of these are the scores in a cricket match by an opener. I mean, -10 we cannot call it, I don't know, but if it is a positive data, we can give some meanings to that. But let's say whatever is the data is, if this is the data x1, this is the data x2, and if you look at the minimum value for data x1 is -10 and the maximum value is 30, and the middle value is 10. So the middle value is this 10 because it's an odd number. So these two and these two are the other extremes, the lower value, lower half and the upper half, and this 10 is this median value. There is no data is repeating in both x1 and x2, so its mode doesn't exist. So there is no mode exist. So just a measure of central tendency is not enough in these two data sets to determine the nature of the data. Let's say if we visualize the two data sets through an individual value plot of the data x1 and x2, and what we see here is x2 is something all towards 10. 10 is the middle value, and because here mean is same and median is same, so that is the middle value, and other values are very much close to 10. But if you look at data x, its mean is also 10, its median is also 10, but it has a much wider spread. So this spread of the data is to be worked out, and that is called the measure of dispersion. So the first measure of dispersion here is what you call it range. Range is simply the difference between the maximum value and the minimum value. So for example, if you have this data set of comprising of 4 points, four values, and if we are interested in calculating its range, so what range is, its maximum value here is 68 and its minimum value is 45. So the range of that data set is 23. So bigger the range, it means bigger the spread of the data. So if the range is a smaller number, then it has a lesser spread of the data. So range is a very crude measure of the spread of the data. Even in this small data set, there is a big spread from maximum value to minimum value. So if you individually plot, one can see easily how this data is spread. So maximum value is 68 and the minimum value is 45, and we can see the difference is 23. So 23 is the spread of this data set. Let's say if we have a data set like this and we have to calculate the mean, median, mode and range, and you know, from the descriptive statistics you can easily get this, and in the next lecture we will see on the mini tab how to do that. But the result shows for this data set is, for example, this is the data of a diameter of a piston ring, which is in millimeter, and there are 10 data point, total count is 10, and its mean value is arithmetic mean is 52.3 and its median value is 52.35, which is actually the middle value of the data. So you have to arrange first them in order for calculating the median, and then then it would be interested in what will be its middle value. And this mode is actually the number like 52.3 is repeating twice, and 52.4 is repeating twice, and 52.5 is repeating twice. So that would be your mode, and its range is nothing here, its maximum value minus the minimum value. So here if you see, its maximum value is 52.5. I think 52.5 is its maximum value, and its lowest value is 51.9. So 51.9 is its minimum value. So the difference between the maximum value and the minimum value would be called as range. Sorry, 52.5 is not the maximum value, 52.6 is the maximum value. So 52.6 minus 51.9 is its range. So 0.6 here, 0.1 here, so it would be 0.7 is the range of this data set. So if this is a bigger number, it means the data has a much more spread towards the mean. or towards the central location of the data. But if it is smaller the number, smaller will be the spread here. Okay, for the same data set, let's say if I am interested in mean deviation, so it means I am interested in how the each individual data set is away from the mean of the data. So what I need is I have the data set X, I just call it, and X bar is, I call it its mean. So we have already evaluated its mean by adding them 45, 64, 68 and 51. We got the mean value of that sample would be 57. So if I calculate 45 minus 57, it comes out to be minus 12, and 64 minus 57 comes out to be a positive number here. Then 68 minus and 51 minus 57. So I have just calculated the difference between the individual value set with the mean value of the whole data set. If you plot this whole data set, then you have some feeling of because 57 is actually X bar, which is the mean value of the data, and we can see 51 is a number which is 6 unit to the behind to this mean value, and 45 is a number which is 12 units behind to this mean value. So and if you see 68, which is 11 units to the ahead of the or greater than the number 57. So 68 is greater than 57 and it is 11 units greater. So mean deviation also, if you work out, it gives you some idea about the spread of the data. One interesting thing happens with this mean deviation. If you take the sum of all the deviations, so you can say sum of x minus x bar, and this comes out to be 0. So this is an interesting result, and we will use this result later on as well in this later part of the lectures. But this is quite an interesting result, that whatever your observation is, if you calculate the deviation of that observation with its mean of the data set, then you end up some numbers which are deviations, and if you take the sum of those deviations, you will end up with 0. So the result of the sum of the deviation doesn't come into any number which cannot be taken as a measure. So in order to get rid of this situation, what we do is we take the same data set, but this time what I do is instead of having the mean deviation, but we are interested in the absolute value of the mean deviation. So how the data set differs with the mean, and how much is the magnitude of that. So minus 12 becomes, if you take a modulus, it becomes positive, and minus 6 also becomes positive. And once you add the sum of the mean absolute deviations, so mean absolute deviations result into a number called 36. So we defined mean absolute, MAD stands for mean absolute deviation, is actually the sum of the deviations from the mean if you take its absolute value and divide by the total number of observations in your data set. So you will end up with a number called mean absolute deviation. So if bigger the value of the mean absolute deviation in a data set, then we say that it has a much more spread. If lesser the value of the mean absolute deviation, we can call that data set to be having less dispersion. Okay, so but still this mean absolute deviation is not one of the popular measure. So there is another measure which is actually variance, which is very widely used measure of the dispersion of the data, in which instead of taking the modulus, what we do is we take the deviation from the mean. Instead of taking a modulus, we take the square and then sum up those values and divide by not the number of observations but 1 minus the number of observations. So we will end up with a quantity called sample variance, and we use a letter S to represent sample variance, which is actually S is a symbol for standard deviation. We will use it later. So if you take the square of that variance, square of that standard deviation, you will end up with a quantity called variance. So if you take the square root of the variance, you are going to get the standard deviations, and we will talk about later, where x bar is nothing, just the arithmetic mean of that sample. So we call it a sample mean. So, and keep in mind, once it is a sample, then the variance would be called as a sample variance. If it is a population, then it would be called as population variance, and we will use a different symbol to represent the variance of the population. Okay, let's do this same data set, which is comprising of 4 numbers, and we are interested in calculating the variance. So we need to make it a table like exactly the same. We have a x value data set, and first take the difference from the mean value is 57 here. So before calculating, as you already have seen, before calculating the spread of the data or calculating the variance, you must have the knowledge of the central tendency of the data, where the location of the central point of the data is lying. So mean is something you need to work out first before working out the variance. So in this column, what I have done is the calculating the difference of the observation data set with its mean value. So you got this number, which we already have seen that sum is 0. But instead of taking an absolute value, this time what I'm doing is in variance, I'm taking the square of that difference. So if you take the square of minus 12 square, then it comes out to be 144, and 7 square would be 49, and minus 6 square would be 36. So and now if you take the sum of the square of the difference, you will end up with the number 350. So if you substitute in the formula for sample variance, this quantity in the numerator comes out to be 350, and in the denominator, instead of n, we have n minus 1. So which we'll talk about later, why it is n minus 1, why not n, because at this point it is just taken as a formula, and we will talk about later why this sample variance is a good estimator of the population variance, where you need to divide by n minus 1 rather than n. So this number sample variance here comes out to be 116.6. So this is how we can calculate the sample variance. So if bigger the sample variance, it means bigger the spread of the data. If smaller the sample variance, smaller would be the spread of the data. The same thing we can do it with the population, because only difference is a notation. Because let's say your data set is comprising of xn numbers, I equal to 1 would be x1 would be the first data point, x2 would be the second data point, x3 would be the third data point, and we have to go to the total number n, which is actually the size of the population. We have chosen small n as a sample size for sample, and use a capital N for the total amount of elements present in the population. And here, instead of x bar, you have the mean of the population, not the mean of the sample, because we are working here for the sample variance. So not the population variance, rather. So sigma is actually the population variance, and s square is the sample variance. And here the mean is in population. We already have seen that the Greek letters are used to represent the quantities involved in population. So for example, mean and variance, and here sigma square, sigma is a letter which is used for standard deviation of the population, and sigma square would be population variance, and if you take the square root, it would be called as standard deviation of the population. Okay, so you need to be careful about for population, because population is a large number set, and at this point of time, if you are dividing by n or n minus 1, it doesn't make any difference, because n is a number which is actually representing a bigger population, whereas in sample we have a small sample size, so n minus 1 is going to make a difference. But capital N, we are not writing capital N minus 1, we are just putting up capital N. So that would be the formula for calculating the population variance. Standard deviation is nothing, just the square root of that sample variance. Whether it is a sample variance, then it would be called sample standard deviation. If it is a population variance, then it would be called as population variance. So we have S square is my sample variance, and if I take the square root, I got S, and S is representing the sample standard deviation. Similarly, for population, if sigma square is representing the variance for a population, then take the square root, you will get sigma, and that is actually called as population standard deviation. So once you work out the formula for variance, you can taking the square root will end up into the formula for standard deviation. Or if you have a standard deviation and if you take the square, you are going to get the variance. So these are not the two different quantities. Standard deviation is defined in terms of the variance, or variance can be defined in terms of standard deviation, vice versa. Okay, so there is an equivalent formula available for calculating the variance of the data. For example, we know for a population variance we have that formula. So what I do is now I expand that sigma notation with a minus b whole square formula, and I will be able to calculate the square of the data set minus 2 times the value of the data set times mu plus mu square. Mu square is actually the mean of the population mean, and n is the size of the population. Capital N is the size of the population. So I have that formula. Now I need to use my sigma notation, and this sigma is being applied and index wherever I is index is there, sigma is being applied. So apply to this term, I apply to this term, and what I have to write for mu square, because 1 upon n is a multiplier, that is actually divided by n, so 1 upon n is a multiplier, and mu square has no index. So but we need to calculate the sum of the value from first value of I to be 1 up to n, to capital N. Then the sum would be obviously would be the 1 plus 2 plus 3 up to n. We can say that the whole because this is the number 1 and there is no index associated, so the sum comes out to be capital N, because here there is 1 is having no index involved, or once xi has an index, then we have to apply index to the x. For example, I is 1, then it would be x1. If I is 2, then it would be x2. Then x1 plus x2 plus xn represent the sum of the values of x up to n. Here it is just sigma of 1 would be actually the sum would be the total number, and because 1 multiplied by n would be the same as n, and if this n and this n cancels out, we can simplify this expression, and we know that this is the sum of x, and sum of x divided by the total number of observation, it would be called as the population mean. So minus 2 mu plus mu multiplied by mu would be mu square. So minus 2 mu square would plus mu square would be minus mu square. So from this formula you end up with this formula to calculate the variance of the population variance. So which is nothing, you can what can you do is take the sum of the observations, whatever your observations are. If you take the square and take the sum of the square of those values, and then divide by n, and subtract with the square of the population mean, because in order to calculate the variance, which is the spread of the data, you must have a knowledge of the central tendency of the data, where mu is representing the mean of the population, which is actually the central tendency of the data. So this becomes an alternative formula for population variance. Similar work can be done with the sample variance, so where xi is an observation and s square is the sample variance, and if you take the square root, it will be sample standard deviation. So that would be the formula. What you need is whatever value of x is, take the square and sum up to the sample size. Small n is the sample size, and then what you do is take the sum and take the square, divide by n, and in the denominator you have n minus 1 because we are talking about sample, and capital N we divide always when we talk about population. So this is what you need to remember, the difference between the two variances or two standard deviations. Let's say we apply this formula to the this data set. So what I need is in alternative formula, I need the value of x and I take the square of those values, and then what I need is I need sum of x, which is 228 in this case, and sum of x square. So 45 square would be 2025 and 64 square would be 4096, and then sum would come out to be 13346. So here this term is 13346 minus 228 square divided by 4, and then in the denominator we have n minus 1, which is the sample size here is 4. So you see, even in this alternate formula we got the same sample variation we have evaluated from our basic formula, where each data set is subtracted with the mean. So we calculate the mean deviation and took the square and take the sum and divide by n minus 1, you got the sample variance. So the same result has come because it is the same data set. Okay, so what is the point of calculating the spread of the data? We have already seen that there are two data sets are given, A and B, and if you see their mean values, their data set A also has a mean of 20 and data set B also has a mean of 20. But what you see here is in data A, which is a blue data set, has less spread, whereas data set B has a more spread of the data. So this spread of the data is actually represented by its variance, or if you take the square root, it is represented by standard deviation. So for data set A, which is blue in color, having less standard deviation, which is 11.19, and 11.19 is a bigger number, which is true for B data set, sorry, and 6.84 it is smaller number, which is a data set for the blue A data set. A is the blue one and the red is the blue one. Red is the B and blue is representing A. So this bottom value is representing more spread of the data. 11.19 is a bigger number than 6.8, and you can see the spread of the data for B is much bigger than the spread of the data of A. And so this gives it, even though both data set have the same means, same central tendency of the data, but the spread of the data is different, which actually gives you the distribution by which the data set is spread about mean. So how much it differs from mean. So the B data set has more difference compared with the mean value compared with A. So that is the importance of this spread of the data. Okay, there is one last parameter in today's lecture is coefficient of variation, which is nothing, just take the ratio of the mean and the standard deviation. When you express in percentage, you will end up with a number called coefficient of variation. So whatever your standard deviation, if you divide by mean and multiply by 100, then it is called as coefficient of variation. Since we are talking about the standard deviation of a sample and it is a sample mean, and that's why it is called for sample, coefficient of variation for sample. And similarly, the coefficient of variation for population would be population standard deviation and population mean. So this would be the formula for calculating the coefficient of variations. And we will see that, for example, in this example, we have two data sets, mean value of data let's say you compare the two methods for glucose measurement. One is called hexokinase method, other is called glucose oxidase method. We call here method A and method B. The mean value of the method B, which is the central tendency of the data, is 120, and the standard deviation of the method A is 4.8. And for data B, method B, the mean value or the central tendency of the data is 100 and the spread of the data is 4. So which method is more precise? So if I ask you this question, and so we cannot answer this question only on the basis of the spread of the data. For example, method A has more bigger standard deviation than method B. So we can say method B is more precise than the method A. If we decide only on the basis of standard deviations, and but we are not taking into an account the central tendency of the data. But in formula for coefficient of variation, we see that if you take the judgment, then you can learn that method B is more precise than the method A. But if we calculate the coefficient of variation for method A, which is nothing, the standard deviation of the sample method A divided by the mean of the method A. So for method A, standard deviation is 4.8 and mean is 120. So the coefficient of variation comes out to be 4%. If you calculate the same coefficient of variation for method B, which standard deviation is for that sample, for that method B is 4 and the mean is 100. So what we observe that both the coefficient of variations are same. So you cannot decide just on the basis of standard deviation. So because the standard deviation for B is smaller than A, so what we can say here, we cannot say which data is more precise only on with the knowledge of the spread of the data. But if you calculate the coefficient of variation, which actually takes into an account both parameters, like it takes into an account the effect of the spread, which is the standard deviation, and the effect of the mean of that, which is the central tendency. So coefficient of variation takes into an account both factors of spread of the data as well as the central tendency of the data. And from this calculation of the coefficient of variation, if there is a higher coefficient of variation, it means less precise. If it is a smaller coefficient of variation, it means it is more precise. So our initial judgment based on standard deviation becomes wrong, where we say that the B is more precise. But here, from the knowledge of coefficient of variation, we conclude that both methods have the same coefficient of variation. So we cannot say which one is more precise or which one is less precise. So that is important aspect of coefficient of variation, because it takes into an account more information. You have a data set, you calculated it central tendency, you calculated the standard deviation, and in the formula for coefficient of variation you are using both of these informations. So once you put more information, then you are more knowledgeable about the different types of the methods based on their statistical parameters like mean and standard deviations. And this is why we have learned very important parameters of measure of central tendency and measure of dispersion. There is one more measure of parameter. One is more parameter of measure of dispersion, that is actually called as quartiles and interquartiles. So we will talk about in this next lecture, but here we stop this lecture.